Hello everyone. Welcome to lesson number 3. In this lesson, we're going to take all the information that we took from the first 2 lessons and apply them to a circuit. We're going to solve this whole circuit. I did write our rules up in the corner here for a reminder. I total equals I1 equals I2 equals I3. E total equals E1 plus E2 plus E3. And R total equals R1 plus R2 plus R3. Those are the rules that we're going to use today, and we're going to use Ohm's law. I'll just put that down for a reminder. I equals E over R. Perfect. What do we know in this circuit? Well, first of all, we know our source voltage, but we don't know our I total. We do, however, know our 3 resistances. We have a resistor here, R1, a resistor here, R2, and a resistor here, R3. These are our loads. What we need to solve is our I total, and we need to figure out the volt drops at each resistor. Now, the first thing that we can do here is I'm going to say we can add up our R total. We have 3 resistances. R total equals 6 ohms plus 12 ohms plus 16 ohms, giving us 34 ohms. Nice. We also know our E total, and that's 240 volts. Couldn't we use Ohm's law right now to figure out what our I total is? Could we put 240 volts over top of 34 ohms of resistance, giving us 7.059 amps. Now, what's special about our amperage? It's the same all the way around. I'm going to put that in. 7.059 amps. 7.059 amps. And finally, 7.059 amps. Also, because I know my polarity, I also know the direction of current flow, and that's going in one direction, in a clockwise direction. Here is where I total lives. I total equals 7.059 amps, and that never changes. Every resistor in this circuit, in this series circuit, is going to see that amperage. Now that I have my R, my resistance, and my current for each of these resistors, I can also figure out what my volt drops are and then solve this circuit. I think you will remember from one of the previous lessons that the E equals I times R. So we're going to take I and R for the resistor 1, and we're going to multiply them to get our E1. And I got 42.354 volts. Neat. Couldn't I go to the second resistor and do the same performance again? This time I'm going to multiply R2 with I2, giving me 84.708 volts. Excellent. Now I'm going to continue on to the third resistor, and I'm going to take R3 and I'm going to multiply I3. Okay, giving me a total of 112.944 volts. Now I do want to explain something really quick. I am rounding these numbers down to 3 digits, 3 1,000ths. It's because it makes it easier to do this stuff on the board. Then I don't have to write everything down. If you'd like to, you can leave all the numbers in your calculator when you're doing these calculations. Excellent. I have solved this circuit. But what I want to do is I want to check to make sure that E1, E2, and E3 equal E total. So over here, I can go E total equals 42.354 volts plus 84.708 volts plus 112.944 volts. And that gives me a total of 240.006 volts, which, according to this, is our voltage total. Do you see how easy it was to solve this circuit using Ohm's law and our 3 series circuit rules? Now that we've completed that last circuit, I've got another practice circuit on the board here. This is a series circuit again, and I think now we're going to analyze it and see what we can discover about this circuit. Let's solve for the volt drops, E1, E2, and E3. Now let's take a quick look at our circuit and see what we've got going on here. We have 347 volts, that's our E total. We also have the resistances for R1, R2, and R3. Well, guess what? Can't we use our series rule? Don't we just need the sum of our resistances? I think we have 15 ohms plus 25 ohms plus 12 ohms, giving us an R total of 52 ohms. Well, if I know R total and I know E total, can I use Ohm's law? Well, yeah, of course I can. We can do I total equals 347 volts over 52 ohms. Now, if I do the math, I get 6.6731 amps. Now we remember from the last few lessons, if we have current, isn't it the same no matter where we are in the circuit? So let's quickly write that out. So 6.6731 amps is I1. I2 is 6.6731 amps. And I3 is 6.6731 amps. Excellent. If I have that information, can I move back into Ohm's law? If I want to figure out the volt drop that's happening at R1, R2, and R3, I just have to multiply the current and the resistance for each one. Over here, I got 100.096 volts. Excellent. Now I'm going to move to E2. I took R2 multiplied by I2, and I got 166.8269 volts. Come down to R3, resistor 3, and multiply my current and my resistance, giving me 80.076 volts. Now, I've solved the circuit. But what I really want to do right now is verify this rule up here. Does ET equal E1 plus E2 plus E3? So let's look. I'm going to add my resistances, or my voltages together. ET equals 100.096 volts plus 80.076 volts plus 166.8269 volts, giving me an E total of 346.9989 volts, which if we round up is 347 volts, which is what our source voltage is. That's the end of this lesson. In the next lesson, we're going to be working on more difficult circuits. See you next time.